In this video, we discuss lesson 7.1, which is about estimating a population proportion. These slides are based on slides provided by Pearson to accompany our textbook and modified by me for our course. This is the first lesson and one of two lessons from chapter 7, which is about estimating parameters and determining sample sizes from Essentials of Statistics, 6th edition by Mario Triola. I believe there are 3 sections in the textbook, but due to time constraints, we're only covering 2 in our course. 7.1 is about estimating population proportions, and 7.2 is about estimating a population mean. 7.3, I believe, is about estimating population standard deviation and population variance. Now, chapter 7 is the beginning of what's called inferential statistics. And this is a little bit different from descriptive statistics, which we studied at the very beginning of our course. So let me define those 2 terms for you and then talk about the major activities of inferential statistics. So descriptive statistics, this is what we did in chapters 2 and 3. This is the branch of statistics in which we describe data. So when we were coming up with those measures of center and we're describing data by stating what that center of the data set was. And then we were looking at measures of relative standing. So we looked at z-scores as measures of relative standing. We looked at percentiles. We looked at quartiles. And we're basically looking at how data values compare to other values in that data set. That was part of descriptive statistics. We measured variation with standard deviation and variance. And we looked at a lot of probability, or not probability, we looked at frequency distributions in the form of tables. We looked at histograms, which are just graphs of frequency distributions. And all of this was just to summarize and organize and describe data that had already been collected. It was all about describing what we know, or making sense of just lists and lists of numbers and saying, well, what do these numbers tell us? Let's summarize it and describe it here. That was chapters 2 and 3. Now, inferential statistics is different. It's not about describing the data that we have. Here, we're trying to use sample data to infer something about a larger population. We'll be doing this in chapters 7, 8, 9, and 10, but this inferential statistics is based on the ideas that we covered in chapters 4, 5, and 6. So there are 2 major activities of inferential statistics. The first is to use sample data to estimate values of population parameters, such as the population proportion or population mean or population standard deviation or population variance. That is the focus of chapter 7. Now, all of the ideas here are based on ideas that we studied, in chapters 4, 5, and 6. So if you don't understand probability, this section may not make sense. If you don't understand probability distributions, discrete probability distributions, this may not make sense. And in chapter 6, we talked about continuous probability distributions, particularly normal probability distributions. And then we said, okay, let's sort of zoom out and then look at not just the distribution of some sample, some continuous random variable from some sample, but let's think of the sample statistics as continuous random variables. Let's look at the distribution of a sample mean or a sample proportion or a sample standard deviation, and then see if we can use that to say something about the corresponding population proportion or the population mean or the population standard deviation. So all of that was in chapter 6 when we studied normal distributions. We also talked about the central limit theorem there, which focused on that sampling distribution of sample means. So all of that is relevant and important to understanding chapter 7 and understanding it well. So make sure you really are comfortable with those ideas in chapters 4, 5, and 6. It'll help you with your understanding of what we're going to do from here on out. But chapter 7 focuses on this first point of inferential statistics. We want to estimate values of population parameters using sample data. Now, chapters 8, 9, and 10 focus on using sample data to test claims or test hypotheses made about population parameters. If you've ever heard the results of some social science study that said men tend to be this way and women tend to be this way, you might ask yourself, like, how do you even know that that's true? How are they able to compare those two groups? How do you measure things that seem to be immeasurable? Statistics allows us to do that. And we're able to do that with hypothesis testing, which we'll study in chapters 8 and 9. And then in chapter 10, we talk about correlation and regression, which are related to a particular hypothesis that we'll make in chapter 10. So let's focus on lesson 7.1 for right now. 7.1 is again about estimating population proportion. So we're going to make inferences about the population proportion in two ways. First, we're going to come up with a point estimate of the population proportion. It turns out that the sample proportion p hat is the best point estimate for the population proportion. We're going to talk about why that's true, and then we're going to review how to compute p hat. And then we're going to say, okay, p hat is a point estimate. It's a single value. The actual population proportion is probably not equal to that single value. I want to know, how good is that single value at estimating what I intend for it to estimate? Well, confidence intervals will allow us to answer that question. Here we're going to use that sample proportion, p hat, to construct a confidence interval estimate of the true value of the population proportion. And it's really important that we understand how to interpret confidence intervals as well. And then lastly, after discussing point estimates and then confidence intervals, which is an interval that allows us to estimate the true value of that population proportion, we're going to say, okay, what if I know what my margin of error ought to be? And what if I know what my desired level of confidence is when I come up with my confidence interval? So I know how large that interval is going to be, how confident I want to be about my answer, and also what that margin of error should be. If I know that in advance, I can find the sample size necessary to estimate the population proportion to that desired margin of error or desired accuracy at the desired level of confidence. And this is really important because if you want to be this accurate with this level of confidence, you might want to know how large a data set should you collect? How much data do you need in order to get results that look like that? We'll have some formulas that will allow us to do that. So here are our learning outcomes. The first is to find a point estimate of the population proportion. Turns out to be the sample proportion. I'll also want you to explain why the sample proportion is the best point estimate of the population proportion. We'll talk about that in learning outcome number 1. In learning outcome number 2, we're going to describe confidence intervals and why we use them. Then we're also going to define the confidence level of a confidence interval. They're not exactly the same thing, but those two ideas are interrelated. And then we're going to talk about how we correctly interpret confidence intervals and confidence levels. We want to make sure not to interpret them incorrectly, as they are often interpreted incorrectly. And then in our third learning outcome, we're going to describe the rationale behind the definition of critical values and compute critical values corresponding to a given confidence level. This is a key component in computing confidence intervals for a particular population proportion that we're trying to estimate. So we need to know how to compute critical values, and we want to understand what they mean and why we're coming up with these. And also, in order to find a confidence interval, we need to define the margin of error and talk about what that is. So we're going to define the margin of error in learning outcome number 4, and then finally use it along with that critical value that we talked about in learning outcome number 3 to construct a confidence interval for that population proportion P. And then lastly, we're going to answer that sample size question. We're going to find the sample size necessary to estimate a population proportion to a desired degree of accuracy. That means with a certain margin of error and a desired level of confidence. And we're going to talk about what that means in learning outcome number 2. So that is lesson 7.1. I will see you in the next video to discuss our first learning outcome.